Hi guys, this is Mina and welcome back to my channel. Today we are going to learn how to design a relational data model using the three normal forms. Relational data model is also known as the corporate information factory architecture. Although dimensional model is also a form of relational database, the term relational database has often been used to refer to the corporate information factory architecture. So in this video, we are going to stick to the universal term, relational database. In my previous video, dubbed Introduction to Data Models, I introduced you to the types of data models for designing a data warehouse, which are the relational and dimensional data models. And I also explained based on a case study the stages of data modeling, which are the conceptual, logical, and physical modules. I also have a video on dimensional data modeling techniques explained based on a case study. Feel free to click on the links in the description section to watch these videos, especially the introduction to data modeling video, as it will help you to understand what we are going to learn in this particular video. Okay, at the end of this tutorial, you would know what a relational data model is. You would be able to design a relational data model and understand the three normal forms. I'll also explain the stages of data modeling, and we are going to base all our explanations on a case study. So moving on to today's topic, what is a relational data model? It is the process of organizing data into multiple related tables using the normalization approach. This technique was invented by E.F. Codd and propagated by Bill Illman. So you would ask, what is data normalization? Well, it's the use of set of rules to break a chunk of data into multiple related tables, and the purpose of that is to minimize data redundancy. Although there are several data normalization rules, in this tutorial, we are going to discuss the first three normal forms, or the first three normalization rules. And if you are able to effectively apply these first three sets of rules in your relational model, your data will be well normalized, and trust me, you won't be needing any other subsequent type of normal forms. But for your knowledge, you can read further about the other normal forms. I mentioned that we normalize data to minimize data redundancy. So what is data redundancy? It is a term used to refer to duplication of data within a database or even orphan records present in a database. And you will see this as we move along in this tutorial. As I've mentioned previously, our explanation of data normalization today is going to be based on this case study, and I've provided a copy of the case study below this video in the description section, so feel free to refer to it as you follow along. And in this case study, we have a company that has several stores in multiple cities. The company manager wants us to track product sales in all the stores and design a data model that would meet the company's needs. He also provided us with source data, and this is the data that he gave to us as data modelers to use to help him solve his problem. In relational data modeling, this table is unacceptable. At first glance, we can easily see that even this table violates the first normalization rule or the first normal form, because we have more than one values in some of the columns separated by comma, and also we have different data types within a particular column. For instance, we have this 3 value, which is an integer, and then we also have 4, which is a text data type. We cannot mix data types within a particular column. We have to stick to one data type. So we need to resolve this table, and the first step is to normalize this table to the first normal form. The first normalization rule states that each attribute must contain a single value, and each value within a particular column must be of the same data type. What do I mean by that? Taking this table that the manager gave to us, in order for us to certify the first normal form, each column, for instance, taking the city ID column, each column has to contain a single value. So we cannot have 1 and 2 all in the same row. We have to take one of those values to the next row. So we have to take 2 to the next row and do the same for 3 and 4. So in this table, we're supposed to get 4 rows. So at the end of the day, for this original table to certify the first normal form, this is how it's supposed to look like. The first column, which is the city ID, has 1, 2, 3, 4 values. So we break them down to 4 rows. And then we move on to the city name, Winnipeg, Brandon. As you can see, it looks as if the 1 represents Winnipeg and 2 represents Brandon. So we have broken them down for the city name. Ideally, you need to talk to the business to find out if that is really how they intended to capture this data. But looking at it, it's supposed to be broken down this way. One thing that I also want to emphasize on is this product name. You can see that we have only one product name. However, we have 2 city names, city IDs, and store name, which tells me that this particular product name, which is crackers, was purchased 2 times. But because it's the same product name, they decided to just write it once. So I have represented it here 2 times. So in Calgary, crackers was bought, and also in Edmonton, crackers was sold. Okay, again, you need to talk to the business just to confirm that this is what they actually intended to do. Under quantities sold, we can see that there are 2 quantities represented here. One of the values is an integer and the other is a text. We need to maintain the same data type for our table to be in the first normal form. So as you can see, I've stick to just one data type in this particular quantity sold column. So you have 2, 3, and then the next row we have 4 and 4. I've also done the same thing for the amount column. Okay, so what we have done now is we have separated the data in this table into multiple rows, and this table satisfies the first normal form. Moving on to the second normal form, the rule states that the table must first be in the first normal form and there must not be any partial dependency of any column on the primary key. What does that mean? Let's take our first normalized form table and see how we can conform it to the second normalization rule. Here we have city name, which fully depends on the city ID. The city ID is a unique identifier of the table or the primary key. So city name fully depends on city ID, but we cannot say the same for the rest of these columns. So in the second normal form, there shouldn't be any partial dependency of any column on the primary keys. These columns are not even dependent on the primary key, which is the city ID. So for this table to satisfy the second normal form, we have to move these columns that do not depend on the primary key into separate tables. So for instance, we are going to have to create a table for city name, store, and also for product, just as this. And each table will have its own unique identifier or primary key. So for instance, in this city table, we have city name as the column, and it depends on the primary key, which is the city ID. We also have a store table, which is uniquely identified by the store ID. And also we have product sales table, and the primary key is the product ID, Product name fully depends on the product ID. These two columns, quantity sold and amount, are dependent on the product name, and we are going to resolve this particular issue under the third normal form. So let's move on to the third normal form. For the third normal form, the table has to satisfy the second normal form, and also every non-prime attribute of the table must be dependent on the primary key. To explain this, I'm going to use the product table that we created under our second normal form. This is our product table that we generated under the second normal form. In this table, product name, quantity sold, and amount are the non-prime attributes. And the rule states that all non-prime attributes should depend on the primary key. It is true that product name, which is a non-prime attribute, depends on the product ID, the primary key. However, we cannot say the same for quantity sold and amount, as they are rather dependent on the product name, which is a non-prime attribute, and this violates the third normal form. So for this table to satisfy the third normal form, again, we have to break the table down into new tables and provide primary keys for each of the tables, as you can see here. So now we have the product table, and it is uniquely identified by the primary key, which is the product ID. We also have sales table, which is being uniquely identified by sales ID, and the quantity sold and amount now fully depends on this sales ID primary key. So at this point, we can say that our product sales table has been normalized to the third normal form. So far, we have been able to normalize our big chunk of table into 4 tables. But remember, this is a relational database, so we have to show relationships between these tables. And to do that, that's when my storytelling skills comes in. Think of it this way, that you have a city, and in each city, you have a store. So I'm going to link the city table to the store table as this. Also, within each store, sales are being made. So I will link the store table to the sales table. We also have product table, and you know that products are the items being sold. So it will make sense to link the product table to the sales table. So this is the relationship that you can generate for your normalized tables. The way to indicate that a table in a relational database is linked to another table is if you link them together using their unique columns. Oftentimes, the primary key in table A will have to be listed in table B as a foreign key. So for instance, in this city table, I have city ID and city name. City ID is the primary key. So in order to link this city table to the store table, I have to include the unique identifier of the city table, which is the city ID, in the store table as a foreign key. So city ID, which is a primary key in the city table, will be included in the store table as a foreign key. So this establishes the relationship between the two tables. Foreign key also ensures referential integrity between two tables, such that if data does not exist in the city table, the database management system will not permit you to enter that data in the store table. For instance, it is impossible to have this row in our database management system. Why? Because we do not have any city ID 8 in the city table. So this is going to throw an error if you try to enter such data in the store table. 8 as the city ID has to be listed first in the city table before it can be added to the store table. The only time you can be able to do that is if there is no relationship between these two tables. But to ensure that accurate data is being stored in our database, it is always advisable to have a relationship between these two tables. So this should be our correct relational data model for the case study. If you have been following our introduction to data modeling videos, you would know that up to this point, we have covered the conceptual and logical models. At this point, I have a question for you. If the manager now wants us to keep records of all categories of products sold by each salesperson, how will our design look like? Remember, he now wants us to keep record of all product category, so that can be one table, and also salesperson. So salesperson is also going to be another table. Okay, I guess you are done now. If you answered it correctly, then you should get a model that looks like this. Okay. Unlike the salesperson table, which links directly to the sales table, the product category links to the product table, and then the product table to the sales table. You cannot link the product category table directly to the sales table because you already have a product table, which is a subdivision of product category. So it's better to link the product category to the product table, and then the product table goes to the sales table. More like a hierarchical form. This is the highest level, comes to the lowest level, and then it's being sold. Since we have covered the conceptual and the logical models, the third and final stage of our relational data model will be to create these tables in a database management system, such as SQL Server Management Studio. And this stage is called the physical model. In designing a physical model in a database management system, you have to specify all data types as well as primary and foreign key relationships and other constraints that you want to give to your tables. So this brings us to the end of our introduction to relational data models. Feel free to watch my videos on how to create tables or physical model in SQL Server Management Studio. In fact, try this out and let me know in the comment section how it goes. And if you need further assistance from me, I would gladly do that. Thank you for watching this video and have a great day. Bye bye.